Today's lesson is actually going to be two short sections together, 11.1 and 11.2. We're going to talk about the areas of parallelograms, triangles, trapezoids, rhombi, and kites. So you already know some of these formulas. The area of a parallelogram is base times height. The base, right, the base could be either the top or the bottom, and then the height has to be perpendicular to the base. Sometimes we'll view it outside the shape, right, so sometimes it'll be here with a little right angle symbol as well, and sometimes it'll be shown inside. In our first example, this is a little harder one, they give us the base is 21, right? This 8 is part of that 21, but it's not actually the base, but they don't actually tell me the height. They tell me this diagonal length. But what I have here is a little right triangle. And anytime I have a right triangle and I know two of the three sides, I can do Pythagorean theorem to find the third. So if this is my height, it's going to be 17 squared equals h squared plus 8 squared. So if I'm using my calculator, I get 289 equals h squared plus 64. If I subtract 64 from both sides, I get 225 equals h squared. And then if I take the square root of both sides, I get 15 equals h. So the height of my parallelogram is 15. A lot of times when I'm dealing with area problems, I write down the formula for myself, and then I make a list of all the components. So area of a parallelogram has a base and a height. I already established my base is 21. I established my height is 15. So I get to plug both of those numbers in, 21 times 15. So my area is 315, and all areas are square units because you're multiplying two different dimensions. So we're going to deal with centimeters squared for this problem. And that's my answer. So go ahead and try the next one. Notice that the 24 is on the dashed line, so that means 24 is our height. And we have two different numbers down here. We're looking for the base value. The only part that's part of the parallelogram, that's the base. So go ahead and find the area, pause, and when you're ready, come back and check your answer. All right, so the answer for this problem is 552 square feet. We'll do one more example of a parallelogram, but this is even harder because we have to think back to Chapter 8. I know Chapter 8 was a really long time ago. They give us a 45, 45, 90 triangle. And if you recall, 45, 49, 45, 45, 90 triangles are isosceles right triangles. So whatever this length is here, it's also here. So I know since this is 9 yards, this is 9 yards, so now I have my height. So my base is the entire 17. Height is 9. I just found that because of my 45, 45, 90. So my area will be 17 times 9, or 153. And that's yards squared. All right, the next shape is a triangle, and I know that you know this formula. Area of a triangle is 1/2 times base times height. It is sometimes written as BH over 2, that's fine, but we usually look at it as 1/2 times base times height. In this section, though, because we are trying to move past what you already know, we're looking more at obtuse triangles that might not have the height on the inside. In this case, the height would be on the outside. So you may have to do something extra to find that height first. Also, because this is not technically part of the triangle, this measurement would not be part of the base. So in example 3, we're going to find the area of this triangle. The base is just this, just the 19. So B equals 19. My height is 30. They're giving me that measurement here. So now I could take my base and height. That's everything I need because I know it's 1/2 times base times height. So that's going to be 1/2 times 19 times 30. So the area for this one will be 285 inches squared. All right, you're going to go ahead and try the next one. You have all the information you need to do it. Find the area, pause, and check your answer when you're done. All right, so your answer for this one is 20 square inches. Again, we're going to do one that's a little harder. So if you notice in this one, they have dashed lines outside the picture. Neither of these represents the height. This right here is our height. So we have to find that. But again, I have two sides of a right triangle. I could do Pythagorean theorem to find it. So we're going to do 13 squared equals 5 squared plus the height squared. So it's going to be 169 equals 25 plus h squared. It's going to be 144 if I subtract 25 from both sides equals h squared. So 12 is my height. So the base of my triangle, remember we're only looking at the part that's shaded, the only part that's actually the triangle that we're dealing with. So that's just the 29. And my height was 12. So I have everything I need. That's 1/2 times 29 times 12. So that's going to be 174 square centimeters. All right. You've probably actually already seen area of a trapezoid as well. So trapezoids have two different bases that are different measurements and a height. And again, the height can be drawn inside the figure or outside the figure if it's a really funky looking figure. So we're going to have 1/2 times the sum of base 1 and base 2 times the height. It's also sometimes written as base 1 plus base 2 times height all over 2, right? It means the same thing. So for 11 here, we know we're going to need base 1, base 2, and height. Base 1 and base 2 are interchangeable. Doesn't matter which one you have where. So I know my two bases are 16 and 6. And then the height, or the distance between the bases, is 12. So plugging in to 1/2 times base 1 plus base 2 times height, we're going to have 1/2 times the sum of 16 plus 6, all times 12. So if you're calculating this, we're going to do 16 plus 6 first. So we're going to get 22 there. And then in our calculator, we could do 1/2 times 22 times 12. And we should get 132 feet squared. All right, you go ahead and try the next one. We are looking for the area again. Pause, and when you're ready, come back and check. All right, you should have gotten an answer of 678.5 square feet. So I don't know where that went. This is supposed to be our formula for the area of a rhombus and a kite. So I'm just going to put it here. So in a rhombus and kite, we're not going to deal with the actual sides. So for a rhombus and a kite, we are going to deal with the diagonals. And if you recall, diagonals are the parts that go through the shape. So if I had a rhombus here, I have the diagonal here and here. Remember that these are the same and these are the same. That's important to remember in a rhombus. But altogether, that could be diagonal 1, that could be diagonal 2. So the area is going to be 1/2 times diagonal 1 times diagonal 2. 1/2 d1 times d2. Same idea for a kite. If you recall, kites had two sides the same there, two sides the same there. We had diagonals. And only these were the same. These were different. But it's still diagonal 1, diagonal 2. It's the same formula for both shapes. So in our example here, we want to find the area of the rhombus. So this little part is 12, which means this is also 12. This little part is 10, which means this is also 10. So I know I'm going to have to identify diagonal 1 and diagonal 2. So if we called this diagonal 1, 10 plus 10 is really 20. And if we called this diagonal 2, 12 plus 12 is really 24. So if I use 1/2 d1, d2, that's going to be 1/2 times 20 times 24. All right, so that gives me an area of 240 square feet. All right, you go ahead and try the next one. Find the area of this rhombus. Pause, and when you're ready, come back and check your answer. All right, we should have gotten A equals 84 millimeters squared, right? One diagonal was 6 and 6 or 12. The other was 7 and 7 or 14. So it's 1/2 times 12 times 14. All right, the next example, it's a kite now. We're going to find the area of the kite. It's still 1/2 diagonal 1, diagonal 2. And in this case, they're giving me the entire diagonals, right? From this point all the way over is 16. From this point all the way over is 9. Remember, it doesn't matter which one we call what. So diagonal 1 I can call 16, diagonal 2 I can call 9. And I'm still going to have 1/2 times diagonal 1 times diagonal 2. So it's going to be 1/2 times 16 times 9, or 72 square inches. So go ahead, try the last problem here. Pause, and when you're ready, come check your answer. All right, we should have got an area of 60 square meters for this one. All right, this slide is just a combination of all of the different formulas. So we have two different representations of a parallelogram. We know the area is base times height. Two different representations of a triangle. It's 1/2 times base times height. Two different pictures of a trapezoid. It's 1/2 base 1 plus base 2 times height. And then for the rhombus and the kite, 1/2 diagonal 1 times diagonal 2. And that's it for this lesson.